Hello, today we are going to be starting Chapter 14, Chemical Kinetics. Hopefully you'll remember from Regents Chemistry that kinetics has to do with the rate of the reaction. So today in our video, we are going to be looking at factors that affect the reaction rate. Then we also will be going a lot more in depth with this and really looking at why those factors change the rate of the reaction. And also we'll be talking about reaction mechanisms, which is exactly how the reaction occurs. All right, so these slides here should be a review of some things that we kind of assume as common sense at this point in time. So we know that temperature affects the rate of the reaction. And just as a reminder, that has to do with the collision theory. Collision theory is that the molecules need to collide in order to react. And when they do collide with each other, they need to have sufficient energy and the correct orientation. So they have to hit in the right spots for the reactions to occur. And we know that increasing the temperature increases the rate of the reaction because we're increasing the average kinetic energy. So on average, our molecules are moving faster. When that happens, the particles will collide with more kinetic energy, more force, so they will have more effective collisions, and they will also collide more frequently since they are moving at a greater rate of speed, and that will produce more collisions. So increasing the temperature increases the rate of the reaction because it increases the sheer number of collisions, and it also increases the effectiveness of each collision since they're colliding with greater force. All right, when we increase the concentration of a reaction, we know that the reaction goes quicker. So if we are reacting a strip of magnesium with 1 molar hydrochloric acid, and then we repeat the experiment using 3 molar hydrochloric acid, we would expect the 3 molar to proceed at a higher rate. So increasing the concentration of the reactant means that we literally have more moles, more particles in there. So therefore, there will be more collisions. And if we have more collisions, we will have more collisions that are successful. We know that adding a catalyst to a reaction will speed up the reaction because it provides an alternate pathway for the reaction to occur that has a lower activation energy. This is one of those things that we're going to take a closer look at, and we're going to talk about how adding a catalyst changes the reaction mechanism. We'll be doing that later on in the unit. All right, if we have a solid reactant, if we increase the surface area, meaning we break it up into smaller pieces, then we will increase the rate of the reaction because more particles will be exposed, so therefore there can be more collisions. When one of our reactants is a gas, if we increase the pressure of the gas, that will lead to more particles, so therefore more collisions. So we remember from ideal gas law, PV equals nRT, the higher the pressure, the more moles that we would have, so therefore more collisions. Or if the if the volume decreased, then you're putting more particles into a smaller area, which again would lead to more collisions. So hopefully this video was a quick review of those factors that affect our reaction rate that we talked about in Regents Chem. Remember, when you are explaining them, you do need to talk about how it changes the collisions.